Here we are, lecture 37. This is grab a handout and then sit with a group to make a group of 2 or 3. We're at lecture 37, the second to the last lecture. We're going to be discussing Stewart, section 5.5. This is new material, the substitution rule. You don't have a recitation session on this material. So today we're actually going to be doing recitation-like stuff. Marissa, maybe you could come sit over with Marie here and make a group of 2. We're going to be doing recitation-like stuff here in class. We're going to have you work on stuff, and then you're going to come to the board and bare your soul on the chalkboard. Friday, we'll discuss the substitution rule some more. We'll have quiz 9. Excuse me. A week from Thursday is the final. It takes place in room 201. I'll be putting information about the final here in the next day or so. All right. Again, please put phones away. So we have a new topic, the substitution rule, and I'm not going to go over this too much. I'm going to go over it in the context of examples. So the idea is that we're familiar with how to find derivatives of functions that are nested. We use the chain rule. We've been doing that for a couple of months now. What about antiderivatives? How do you deal with finding an antiderivative or indefinite integral for a function that has a nested component to it? Well, it's not always possible to find a function that works as an antiderivative, an ordinary function. But sometimes it is possible, and sometimes you can find one using what's called the substitution rule. And so the substitution rule is, I present as this batch of 5 steps. Now, invariably, students will say things like, well, I already know how to do the substitution rule, and I don't do it that way, I do it some other way. There are lots of ways to present your work. But I'm a stickler, as you know, for notation being clear and correct. So, if you learn some way of doing substitution in high school, fine, but you need to be able to show me steps that are clear and mathematically valid. You can't write some wacky thing that happens to give the right answer and just say, well, Mr. Johnson taught me to do this. Well, Mr. Johnson's not here. You gotta show, valid steps. I'm going to be showing one way to do that, and so here we go. There are these 5 steps, and so tomorrow is Gabriel's, I guess, your proposal, the defense of your proposal. So to become a Dr. Gabriel, he's got to write a great big thesis, and the first part of that is identifying a problem to solve. And so you make a proposal for what you're going to write about, and so that's what he does tomorrow. Okay, grab a handout and join a group. Any groups needing another person? You can join any of these groups of 2 to make a group of 3, but when somebody comes in, I'm going to have you join. Yeah, maybe, yeah, okay, that'll work. So here we go. Here's our first example. Being asked to find that indefinite integral. In other words, find the general antiderivative. Notice that has a part of that, the integrand, the thing inside, we often give the symbol little f of x, is x cos x squared. It's not a pure nested function, but it has a nested component to it. It has a function inside of another function. So let's just follow the steps. Step 1, identify the inner function and call it u. Well, the inner function is the inner function. It's whatever's in the belly of another function. So there's really no choice about that. X squared is the inner function. So x squared is what we're going to call u. Circle that. Now in the book, and I've seen this in other books as well, the authors will sometimes write as if the substitution method or the substitution rule is somehow mysterious. Our book says something like, choose a u that makes the integrand simpler, which is nonsense. There's no mystery about this. For this, we're using this method in a situation where there is an integrand that has a nested function. The only reason we're doing this is because the nested function. So the way you get out of that is you have to get rid of the nesting. So u has to be the inner function. There's no choice. So it should not be mysterious. Grab a handout, and there's a group of one. You can make a group of two. Okay, step 2. Step 2 is we need to build this wacky thing. dx equals 1 over u prime du. And we want to circle that equation. So in order to get that, we need to first find what u prime is. So u prime is, well, if that's u, then u prime is 2x. So I'm going to build the equation dx equals 1 over 2x du. Circle that. Now, why am I circling these? Well, because in step 3 is the substitution step. So we substitute, cancel, simplify. So start with the original integral of x cos x squared, and realize that we have a new version of x squared because we have that circled equation. We have a new version of dx because of that circled equation. That's why I want you to circle these things, to remind yourselves what you're going to do with these things. So we're going to substitute. So then I get x cos u times 1 over 2x du. So I used that first equation to replace x squared with u. I use the second equation to replace dx with 1 over 2x du. That's the substitution part. The cancellation part, well, there's an x on top, there's an x on bottom. So this is the same as cos u, the integral of cos u times 1/2, and then there's a du. And then simplify. Well, there's a multiplicative constant. So when I simplify, I can pull that multiplicative constant out. And I'm left with this integral. The key thing about this integral is that it's a basic integral. It's not a nested integral. There's no x's here. And this is something there, we have an integral rule or an antiderivative rule that applies to this exact thing. I pulled the 1/2 out. So that's what I want to see at the end of step 3. And as I said, this is the substitution rule. So the most important part of this movie is the substitution step. So I want to see, the before and the substitution, and then the result of the substitution needs to be this new clean integral involving just u. So in my grading key, which I've already made for the quiz, one of the things is, do they show a clean integral involving u as the result of step 3? And again, whether maybe you don't call it step 3, maybe you don't have the titles, I would suggest putting these titles here when you're doing these practice problems so that you internalize these steps. Okay, step 4 is to integrate. So I always start my steps with the previous step, and I'm going to integrate. So that's going to be 1/2 sine u plus c. That's the indefinite integral of cosine of u. And then step 5 is to substitute back. So I get 1/2 sine u plus c is 1/2 sine x squared plus c. And let's call that something. Let's call that capital F of x. So what we've done when we find this, we found an antiderivative of little f. So let's check this. And that circled thing is the answer. Notice it has a plus c. So let's check, does capital F prime of x equal little f of x? So capital F prime of x is the derivative of 1/2 sine x squared plus c. So I can use the sum and constant multiple rule to pull that 1/2 out. And then also the derivative of c is 0. And then I have to use the chain rule. So I'm going to have a 1/2. I'm going to have my outer prime. My outer function is sine of parentheses. So I should have cos parentheses. So I should have outer prime of inner of x times inner prime of x. So I'm going to put my original inner function back in there. And then I'm going to multiply by my inner prime. The derivative of the inner function is 2x. And so this is, when I cancel the 2's, I get cos x squared times x. And that is little f of x. So we did find the general antiderivative of little f of x. So again, I can't stress enough. I think it's very valuable to write down these step numbers and to remember that there are 5 of them. I can't count the number of times that I've watched students, read students' solutions, where they go through all this stuff to do this substitution, and then they substitute back. They forget to integrate. They forget step 4. So if you write, step 1, step 2, step 3, step 4, step 5, that will help prod you to remember to do each of these 4 steps, 5 steps. All right. So in your groups, work on on problem number 1, and in a little bit, I'm going to have you all come up. Well, I'm going to have 6 or so groups come up and write problem number 1 solutions on the board. Where's the sign-in sheet? Did it go around? Aha! Gabriel, you could pause that if you would, please.